Okay, North Haven Middle School Grade 8 Algebra Core B students, this video is for you. We are now dividing and simplifying radicals. We already have movies for simplifying radicals and multiplying radicals. This is a part 1 video. At the end of this video, I'll explain what part 2 is going to be about. But dividing is going to be a little bit trickier. But today we're just going to focus on the easier type problems. We're going to be dividing and simplifying radicals using a lot of the stuff already discussed in the prior videos. So hopefully you find this helpful. Before I forget, this is going to help you with the stuff on the 11.5 worksheet. On that PDF, you'll notice 11.5, it is broken into 2 parts. All right, and that's kind of why there's 2 videos. There's a part 1 and a part 2. But this is going to help you with the problems on the first day of the 11.5 worksheet. So that's what this video is here to do. So let's go over something. There's going to be 2 problems up on the board. Or it might look like I'm putting 2 problems up on the board, but spoiler alert, it's actually the same problem. And we're going to see exactly why. So I have 2 technically division problems. I know they look like fractions, and they are fractions, but they're technically 2 things, and I just want to simplify each one. So we're going to go about simplifying it 2 different ways, and by doing that, we're going to find the really, really important rule. So first, the square root of 36 over the square root of 9. So the way I have this written, well, I know the square root of 36 is 6. The square root of 9 is 3. 6 over 3 is the same as 2. So that comes out to 2. So that's one way of doing the problem. Now here I have the whole thing in one giant radical. So to do this problem, first I'm going to simplify what's inside the radical. So I'm going to simplify 36 ninths. So I'm going to simplify that fraction, 36 over 9. I'm going to divide both the top and the bottom by 9. So now this problem turns to the square root of 4 over 1. So really it's just the square root of 4, which is also 2. So realize that if I have a numerator and a denominator, I could find the square root of the numerator, the square root of the denominator, and then simplify. Or if the whole thing is under radical, I could simplify and then get the square root. It really doesn't matter. It comes out to the same thing. So what does that mean? That means that here is a rule we can follow as far as radicals go. It's kind of similar to the multiplying rule we talked about in a prior video. It's that the square root of a over the square root of b, oops, I said b, is the same thing as the square root of a over b. So that's going to be helpful depending on, because a lot of the problems you're going to see, you're going to start here and it might help to go this way, or maybe it's going to start here and it might help to go this way. So it's important to know that these are equal to each other, so I can kind of go in both directions when I'm simplifying radicals, dividing and simplifying radicals. So let's look at an example. That first one, the 36 over 9, was kind of an easy one. Let's just look at another easy one. We'll kind of build to a tough one, and I'm going to stop with the problem that we'll start with in part 2. So here's an easy one, the 36 over 25. So this one's actually a little bit trickier than the one we just did, because now you can't simplify 36 over 25. There's nothing that goes into both 36 and 25. So that means I'm going to have to I'm just going to have to rewrite it. I'm going to rewrite it as the square root of 36 over the square root of 25. That rule we just talked about shows that we can write it like this, and I'm just going to get the final answer of 6/5 or 1 1/5 or 1.2. But we're really going to want the fraction answers here. We really don't want decimals, because we really should be doing these without a calculator. We can use calculators to help us simplify if we can't remember how to simplify fractions, or we can't find a common factor. But for the most part, the fractions are going to be we're going to use, and really the 6/5 is actually the best of these answers, but they are all technically correct. All right, so let's move on to a harder one that has no perfect squares in it, or so it seems. So we're going to do this problem 2 ways. We're going to do the square root of 12/75. So what's the square root of 12/75 come out to? So the first way I'm going to do this problem is I'm going to rewrite it as the square root of 12 divided by the square root of 75. I'm going to simplify it that way. So what I'm going to do now is, if you go back to the first video that I posted, Simplifying Radicals, I'm going to use that. I'm going to simplify the square root of 12. I'm going to simplify the square root of 75. I'm going to see what I get and see if that helps me simplify this whole thing. So if you remember, I'm going to look for perfect squares to pull out of the square root of 12 and the square root of 75, or maybe a common factor I can pull out of both of these. But going along the perfect square route, well, I know that this can be rewritten as, I don't think this one works. Yeah, that's not really that great. We'll use the other one over here. We could use the square root of 4 as a perfect square and the square root of 3. And here, well, I got the square root of 25, that's a perfect square, and I have the square root of 3. Now remember, you're dividing here, you're simplifying fractions, so you should realize that you have the same thing on the top and bottom of your fraction. So the square root of 3 divided by the square root of 3, that's going to cancel out to just 1. So now I'm really left with the square root of 4 over the square root of 25, but these are perfect squares. The square root of 4 is 2, square root of 25 is 5, so I get my final answer of 2/5. So that's one way of simplifying this problem, but it's not the only way. I really didn't have to write it like that. I could have kept it as 12/75 and just see if I could divide this fraction, and I could simplify this fraction by dividing the top and the bottom by 3. I could have rewritten it as 12 divided by 3 is 4. 75 divided by 3 is 25. So 12/75 reduced to the square root of, reduced to 4/25. So 12/75 reduced to 4/25. And now, well, I rewrite that as the square root of 4 over the square root of 25. I get 2/5. I can go about doing the problem that way as well. I get that same answer. All right, we're going to do, I think we'll just do one more example, and then we'll call it. We'll keep these videos short and sweet, so you can work on the homework, and you could pause and rewind these as you go through it. Email me questions, and I'll try to help you out the best that I can. All right, so now I'm going to have the square root of 40. And let's put some variables in here. B to the third. So square root of 40, b to the third, and we're going to put that over the square root of 10, b to the second. All right, so again, we know the two different approaches of going to this problem. The first way I'm going to show is I'm going to try to simplify these radicals and see if that helps us simplify it. So I'm going to deal with the top and deal with the bottom separately, and then try to simplify from there. So 40, there's a 4 in there, which is important. I want to pull out a perfect square, so that's the square root of 4 times the square root of 10. Here I have the square root of b to the third. I'm going to break that up into the square root of b squared and the square root of b. So I'm just breaking down the 40 part into the 4 times 10. I'm breaking down b to the third as b squared times b. I think that's going to be really helpful. I'm going to leave it like that for a moment now. I'm going to look at the bottom. There's no perfect squares I can pull out of 10. So I'm just going to leave it as the square root of 10. B squared, well, I'm actually going to write that as the square root of b squared. And now when I look at this, what can I cancel out? What do they have in common? They both have a square root of 10, so that can cancel out. The square root of b squared divided by the square root of b squared, that can cancel out. So now everything on the bottom is gone. I'm left with just the square root of 4 times the square root of b. Square root of 4 is a perfect square. Square root of b, it's already in simplest form. So your final answer is going to be 2 rad b. That's going to be your final answer. There's nothing more I can do with this. I have to leave that part under the radical. The 2 we're able to do all the way out. All right, so now I'm going to do the same problem one more time. I'm going to simplify it first. So I'm actually going to rewrite it in one giant radical. All right, so same problem, just rewriting it this way. And now I'm going to look to simplify it how I can. Well, this way might actually be easier, because 40 divided by 10, that's just going to be 4. B to the third divided by b to the second, that's just going to be b. So this, everything underneath the radical simplified to just 4b. Again, I'm going to look at that as two parts, as the square root of 4 and the square root of b. Same thing we had right up there, which means we're going to get the same answer. So two different ways of doing the problems. Both ways are correct. It's really whatever your preference is. I think that this is probably what you're used to doing because you've been doing it in the prior lessons in 11.3 and probably in 11.4. But I would look to go this route because it might just make life easier for you. You're really taking what's under the radical and making it smaller and then breaking it up from there. Both ways are right. Just find the way that works for you. Find the way that's comfortable for you. And that's that. All right. I told you this is going to be a short video, so I'm done. I'm just going to preview part 2. So what's going to happen in part 2? How can these get harder? You're thinking they're pretty easy. Well, here I'll give you a problem that looks really, really easy. All right. Square root of 2/3. So radical of 2/3. So again, I could break that up as to rad 2 over rad 3. But this is really, really simple. Simplified. There's nothing I can do. There's nothing more I can pull out. There's nothing more I can cancel out. So you might be thinking you're done here, but the people in charge of math, they like the denominators. They like the bottom number of a fraction to be a rational number, meaning they want no roots, no radicals in the denominator. So this right here is a problem. So what we're going to talk about in the part 2 video is something called rationalizing the denominator. I think Ms. Khan has made a video to help with this, so definitely give her video a look. Her handwriting is a little bit better than mine, and she explains it very, very well. So take a look at that. But in the part 2 video, we're going to talk about how to simplify this, how to rewrite the square root of 2 over the square root of 3 so that there is no radical in my denominator. That's for part 2. For now, part 1 is over. So this should be, I think, Wednesday's night. It's homework of 11.5, the first point of that 11.5 worksheet. This should help out with. Stay tuned for more videos for help with the rest of the week. Thanks for checking in. Stay safe and wash your hands.